Hello, it's nice to meet you here in Tel Aviv. This is my first talk in Tel Aviv in public, so I really appreciate you coming. And my name is Vaidas, and I come from Vilnius. And in Vilnius, Vigs has office, and I'm backend software engineer in that office. So it's a pleasure for me to be here and speak and maybe share some of my experience. So my talk is about TDD, and basically what I wanted to show you tonight is that using TDD, you can progress with implementation without even knowing the algorithm that you need to implement. And another point is that I want to show how to properly do TDD. Basically, after running a couple of code retreats, and if you want to know what is code retreat, it's an amazing event for developers to improve their skills. I realized that a lot of people all the time give the same questions. How to do TDD, how to do it proper way, and tonight I'm going to explain how do I do TDD. And I think this is a really good explanation, but still, don't take it like 100% as correct. This is doing TDD is a state of mind. It's it's where you are in your experience. Maybe after 1 year, I will say, okay, maybe something changed, like I discovered something else, and I will be somewhere else. But I think that this is a really good idea to show what I have now. So I really recommend to go to code retreat events and learn and practice those skills. And today, I will use Roman numerals conversion. So I will convert Arabic number to Roman. So it's just basically, as you see in the example, probably everyone knows. So we'll use this as a small algorithm. And when I speak about TDD, I usually mean driving design by using test-first techniques. And testing is just one part in the process, and everything else is refactoring. Refactoring is the part which we usually forget. So if you know TDD, TDD is you write a failing test, then you have to write as minimal as possible code to pass the test. You get into green stage, and then you have to refactor. And when we speak about refactoring, people usually forget refactoring phase. For refactoring, I use this tool. This is 4 rules of simple design. I think this is the essence and the proper way to do refactoring and drive your design. So TDD by itself, it will not move your design forward if you will not use some kind of concept or some tool to understand how to properly refactor your code. And refactoring is the hard part. OK, so let's start with coding. And I already have a small project ready. I will be using Scala. You don't have to know Scala much. I will not use a lot of important or Scala-specific things. It will be really simple, and I will explain on the way. If you have questions about what I do, I want you to ask them at the end of the talk. I will be using specs, and I will be using SBT, continuous test running. So this is a simple setup. And this talk is not about naming, because as you know, naming is one of the hardest problems in software development, basically cache invalidation and naming. So it will take forever if we will start discussing naming. So we'll just put effort on refactoring and applying duplication removal. First of all, let's start with naming our class. I will take this example and Roman numerals converter test. Now the question is, what should be our first test? We have an example how to write it in this framework, and we can see that it works. But what should be our first test? When I apply TDD, before I start, I always think, OK, so what are my requirements? And it's really the dilemma which requirement to pick first. So my rule is always pick the simplest one. It's very important to keep moving and apply as little as possible effort to have some of the production code. So in this case, I think that we have quite a few easy requirements, and one, for example, is just to convert 1 to I. So let's say that Roman numeral converter converts 1 to I in this test. And what should our test look like? So we still don't have any production code, so this is the time to write a failing and non-compiling test. There, and it should do what? It should take Arabic number, and that number is 1, and should be I. So we have a test, and it should fail. You can see it at the bottom. Now what do? We just create an object. I will use separate file, but usually I do everything in the beginning in the same file. And then when I feel the need, I start moving out things of the same file. So we have this file, but we still don't have method. We create method. It's really nice that tooling helps me to generate most of the boilerplate code, and I don't have to write a lot. Again, my naming is not the best, but it helps, and it should return string, and we don't have implementation yet. So what our test is saying that it tried to run the code, but it got not implemented exception. So who doesn't know, in Scala, those 3 question marks basically stand for unimplemented. This is actually example how to triangulate in the code. You have a test, you write as little as possible, and you keep seeing failing. For example, this test says that, okay, my class wiring is fine, but it's still not implemented. This is also very important to if you're using our programming languages, for example, JavaScript or Ruby. Okay, so what would be the simplest implementation? So if I would write this algorithm without any tests, I would probably have to take a paper, maybe sit for maybe 15 minutes or maybe more or maybe less, and think how to deconstruct this algorithm. Now I don't know anything. I don't have to think. What I do, I just say, okay, this is what is the minimal implementation. And we see all the tests pass. We have still only single test. Now the question is, we are at the part where we are in the green phase, and what do we do now? We should think of refactoring. Okay, so let me look at the implementation. I don't see anything to refactor here. It's so simple. Let's look at the test, and I think this is the same. So we can continue with the second one. So now we're in the second test. And what should be second test? I don't feel anything hard to move with the 2. And I think 2 will force me to implement something else in the test. So what I will do, I will just write another test which will say converts 2 to II. But the problem is that I already feel a tension that I'm repeating myself. I have to write this tedious part of the test. But I'm forced to do this because I still have no duplication. And I can remove duplication only when the test passes. And our test doesn't exist yet. OK, converts 2 to II in numeral. OK, that's too much. And this is usually where CopyPaste comes in, because we're so impatient and we feel this tension. But we should wait a little bit. Should be. OK, cool. We have a failing test. We are good to go to implementation. So what do we do? What would be the simplest implementation? So what I will do, I will check if number is 2. And then return II. Now my question is there any duplication? I'm in a passing stage. And this is a tricky question. Like, it's almost all the time you will find something which duplicates something. For example, in this case, we have a duplication which is really hard to spot if you're inexperienced, but we have two exit paths from the same function. You may consider this duplication, or you can wait it for later one, but I would try to remove it. And to remove it, I need to do a very simple thing, which is, so we removed some duplication. Now we can come back to our tests. And in tests, we have this problem that it repeats itself. The problem is that we have this part which is very similar to this part. It's just a pattern. And if we will go more, it will just be really tedious and really easy to lose the test details. So what I will do, I will extract something like examples. Why do I call examples here? Because this is example-based testing. You may know our types of testing, for example, like property-based testing or maybe something else. But here we are using example-based testing. So the point is that you specify examples, and in the end, you have a test suite which is just like selected list of examples. So what we can do in Scala, we can say, okay, my example is maybe 1, 2, I, and 2, 2, I. And then let's maybe play a little bit and say that. By the way, again about naming, examples probably is very like generic name. If you are good with naming, come up and spend some time to explain what are those examples in this context are. So what I will do, I will say for each, and I will say, okay, let's have Arabic. And I want to have this expression here which says, okay, let converts Arabic. Okay, why don't you shout about my mistakes? Arabic to Roman in Roman converter from Arabic, which takes Arabic and should be equal Roman. Okay, let's run. Let's see what happens. Okay, so we got an exception which says, okay, I know probably where the problem is. Let's try again. Okay, so this loop just caused the problem. So for each is fine here. So you may wonder, or maybe you heard someone saying, okay, this is very bad to do this way because we're moving out examples, like we're parameterizing our tests, and they like remove clarity from the test name. But the point is that the most important part is here, where you have those examples, and the test name is very important when you have a runner here. I think duplication is first thing that you have to remove both from tests and from your production code. And TDD works this way, that you remove duplication, and this way you're progressing. Otherwise, you will end up just building if this, do this, if this, do this, and it will never end. And duplication is the point where you just break it and make your code more generic. The question is, what is our next test? We have 1, 2, and probably I will go with 3, because 3 still moves us forward. It will force me to write something else. Maybe it will force to duplicate something. And my implementation will be number. You see, I still have to do something very, very simple. I cannot just take and refactor it to some abstraction here. I need to see a passing test. OK, so I forgot else. OK, now do we spot duplication? Yes. So I know a little bit of Scala, so I will do a trick here. And it should work. And I will regret this trick later. This is what we as developers do because we know language. And why this is wrong? This is wrong just because it does a little bit too much as needed in this case. For example, the problem is that if you will talk to your math teacher, she will never accept that you can multiply strings or something. It just doesn't work that way in math. OK, so, but I'm a bit like blind. I cannot see this. Let's go. What is our next test case? OK, 4. But you know, is it the simplest one? It's not. So I will do a really stupid thing. Like from first time I wrote this algorithm, I started with 4 and understood that this is really hard case. And now I remember that dealing with 4 is, because I don't know 5 symbol, I don't know this V, I know only I, and it gets really complex. I'm solving 2 important things at once. Subtraction and 5. So what I will do, I will defer it for later. And usually as you do TDD, you have to have a book note, and you just take notes what you should do later. Because this is presentation, I will just use to do. And I'm not even writing the test case. I'm just writing some requirement. And this is important because after I will add more requirements and I will come back to this one, it may be that it will change in the future. Maybe I will not need this requirement anymore. Maybe I will need it in a different way. So I will say, let's deal with 5. Because this one looks simple. I know i's, I will add 5s. And we have a failing test. What do we do? That's very simple. Let's say number equals 5. And return 5. And I should see passing test. And what can I do now? I remove duplication by doing a very simple thing. And still works. Fine. Now, we need another case. I will go with 6. Some people would think that 7 is a good case, but I will argue because 7 is more complex than 6 because it has 2 i's appended to 5, and this sounds like a couple of requirements in one place. So I will use only 6. You can go another way, you can introduce 10. This is just another way of dealing with this algorithm. You will eventually come back to some solution. There are multiple ways to deal it, but my point is that you just pick something very simple. So this is this, and it should fail. And now it gets a little bit harder. I need to do something with the state. So I want to do something like this. And maybe this should, and now I have written var. And I've written it for a very simple reason. Because this is, if I would like to, like, as a Scala developer, all the time I feel this urge to write functional code, but TDD doesn't drive it for me here. So I have to write as simple code as possible here, and only when I have a passing test I can refactor this. So I will use var, which is really imperative. I will maintain state in one variable. let's call it result. And in the beginning, it's just this. Then what we need to do, we will also have remainder. This is quite a huge step, if you can see it. I'm writing a lot of lines of code, and I will assign it number, and remainder, or some, okay, remainder minus 5, and then result, and I have to return result, right? I hope this works. No, it doesn't. Okay. Thank you. Okay, it works. This code looks very, very ugly. Like, I think everyone will agree with this. But the problem is I have no evidence that I can fix it. There is no duplication. So what do? We go and write another test. And that test is 10, because what is, or we can also have a to-do for 9, just because we're going in order. Just to do deal with 9. And this one is another letter. 7 doesn't bring anything new to us, because we have i's already working. And by the way, if I will write 7, I think my tests will not fail. It will not fail. I already think I have this implementation. That's why 7 and 8 it doesn't make sense anymore. Okay, so what do? We just do a simple thing. If this is remainder and it equals 10, let's return x. Okay. Now what we can do, not much we can do. Even this return is hard to refactor, but I will try to do it. So what I'm doing is I will say result plus equals. I need to subtract this value from remainder. So this is okay, it's passing. And now we have, do we have duplication now? Well, not really. This looks very similar, but it's not duplication because the 5 case does more than 10 case is doing. So we need another test, and that another test is, it's 15. And why not 16 or 17? For the same reason. I'm just introducing very small step, and that small step is adding 5 to 10. It shouldn't be something like 5, 10, and maybe I, which would cover more complex case. Okay, so let's have it. And now we need to make this pass. And to make this pass, I will try to do this. And this works. And now we have duplication. And the part duplicated is those two if statements. I can refactor them. So what I will do, I will say, OK, let's have rules. Let's have rules and list those rules in very similar way as we're listing our examples. So let's say that we have 10, which is x. And we have 5, which is 5. And now what I will do, I will say, OK, let's take rules and do the same for each. And this is case on. This is a very nice feature in Scala that you can destructure your tuple, and that tuple is in the list. Arabic, Roman, And now let's fill this one. Arabic, Roman. And it's still passing. So I think we have too much code, so let's delete this part. And let's see if we're still passing. Nice, OK. We're passing. This looks very ugly. It's really imperative. It's not the way a Scala developer would write. But bear with me, we will come to the better solution. So we need another case. In that case, nothing more left. We should start with adding the same x to x. So let's do it. OK, I don't want this one. How do we solve it? OK, I will put while here. And it works. This is this nice moment when you just, if you know that if is a specific case of while, you can do this. I want you to come back to a little bit of the theory. Those rules which help you transform your implementation are called transformation priority premise. And what it says that as you have more tests, or basically as you have more examples and they get more specific, your code becomes more generic. And there is a list of transformations, and basically what I'm doing in my implementation, I'm going over those. Maybe I don't use all of them, but if I see something, I can transform to it. And rule number 10 says that if you see if, more generic version of if is while. So that's why it works. There is explanation why it works. And if you want to learn a new acronym, so this one is TPP. OK, now the problem is that I really hate this code. What can we do about it? Let's refactor maybe. First of all, I don't like those vars. Maybe what we can do, just let's have first var here, or maybe I don't even need this one. Let's do so. Let's have times, which would be remainder divided by Arabic. And let's say that remainder is not this way. We need to divide it by this, by Arabic. And what we need to return, Roman dot times. And this one is not needed anymore. And this one becomes map. This is where I actually enjoy my work, because this is finally coming to functional side. I'm using more abstract declarative programming. And I will say, let's make a string out of it and see maybe it works. Oh, it doesn't. OK, who spots the error? OK, we have remainder, and then OK, that's true. I need to say this, and that result is equals this, and yeah, it works. So we are getting to a better shape. We remove this while completely. Now, what I really hate, oh, by the way, do you remember this I? We still have it. And this is what I've said. If that would be something more imperative like while, we would have got ridden it in this place. This is where it just, we introduced abstraction too early, and that's why it didn't work. And what we can do, I will say this, and I will get of this var. And I will add 1 to I, and I will pray that it works. It should work. Nice. So it's getting better. Now the problem is that we still have part which mutates, and that part I really hate. And what can we do here? So one thing what we can do is to use fold, but in our case, folding would require keeping 2 states, and I don't like this either. So I will use recursion, for example. Recursion should solve it. Let's have a method inside, and let's say, let's call it to Roman, and it will take current number, and it will take rules, which are sequence of what? Sequence of tuple from int to. By the way, you can see that I can do a lot of refactoring safely because I have a lot of tests. I just need to be careful not to introduce more abstractions. I'm just like playing with the same code. And it should return string. And now what do we do? OK, I will write the code which will just use recursive implementation over rules. So let's match rules. Match and case. We have no rules. We will return empty. And case we have rules. I will destructure first element into Arabic Roman. And I will, thank you. This is a missing A. And let's call it maybe rest. And now we need to do one thing. We need to, by the way, I also named it really nicely. So we can fix it to Roman. So I need to pass a number, and that number is, okay, let's calculate the number. Number is times times current number divided from Arabic, and I also need a remainder. And that one is number div Arabic. And now I also need a new result. And that result will be returned. So I need Roman times plus 2 Roman, and we give it remainder, and we give rest rules. Okay, so this one is not needed, and see what happens. Oh, that's very simple. I'm not calling this one. Forgot it. Number, and then just we pass rules, and we don't need this part anymore. Okay, and it works. But there is a problem. I don't like recursive solutions. I want to have tail optimization. And why is this important? Because if you have, well, maybe it's not important with Arabic conversion because it will probably not exceed stack limit. But if that would be something that is very intensive, it would be an issue. It would be possible issue. So let's improve it a little bit by Scala, by the way, supports tail call optimization, which means that recursive implementations can be rewritten in cyclic ones. And but only in that case if the recursive call is in the tail. So we need to have accumulator, and I will call that accumulator result. And I will basically tell to return result here. And I will say that, OK, we need to construct result by calling, and I need to pass empty accumulator. OK, it works. And we have a tail call optimization. It was not that hard because I kind of practiced this a little bit, so I knew, but at first you may spend some time more. Now the question is, I kind of feel that I have, well, maybe I could extract this method or do something else, but I still remember that I haven't finished my algorithm. So what do we do now? I think it's probably the proper time to deal with for, because I don't know the easier requirement here. So what do we do? Let's say we have for. OK, we have a failing test. And OK, let's be naive and add for here and see what happens. And it works. This is the nice way of dealing with algorithms in TDD. You just tackle all the easy cases and hope that hard cases will be solved for you. And this is how it works, because the smaller steps you go, the more algorithm you will implement with different possible generalizations. So the question is, what happens if we add test for 8? Let's try. Just to see if we are cheating. So it has passed, you see. But this test doesn't fail, so the problem is that I never keep tests which are not failing, because they do not prove that something works. They just don't say that like, you should add test to prove that you don't have something. If you add test which shows that something exists, you never know if it actually exists. It just can be a mistake in the test. So let's deal with 9. And OK, so let's try another naive implementation, and I think it will work because you've seen already 4. Cool. Now I think that I have all the fully working algorithm. I will just finish it very quickly without like forcing you to wait. But have you noticed that I didn't even pay attention to corner cases, edge cases like negative input, like error cases, what happens if I pass 0, for example. My idea is that you should always concentrate on easy requirements, and those easy requirements should belong to a happy path scenario. I have a file which is called cheats, and I will do tests very quickly. Your question could be like, should I write one failing test and then add configuration and then continue this maybe, I don't remember how many digits left, but all those digits. I would say that this doesn't really matter because you're not going to see algorithm changing. And if you know this, it's just a configuration. So add this and see it failing. It's important that you still see it failing. And you can implement with a cheat, or just write it yourself at once. So it's not really needed to go step by step and implement all the possible configurations. So OK, it's passing. And I think now we have all the algorithm working. What I recommend all the time to do, there is a sense maybe I did something wrong. Maybe I forgot, I just swapped by accident some letters or did something. So I will test it with some integration test. And to be more quick, I will have this integration test. It's quite complex, that's why I'm using it. And I will add it at the end. And I wish it works. So it works. All the other things that left are quite boring. And what I want to force you to think about is this tail call version is more understandable, or that imperative with a while, or just for each. So this I will leave to you to think of, because it may depend on your level, it may depend on the algorithm, so never go for something which is hard to comprehend. And another takeaway is that if you start doing TDD really with the small steps, there is a big chance that you will end up with imperative code. It will be driven by the smallest implementation steps, which is actually not bad because you will have more room to do a proper refactoring. And with this, I would like to say thank you. OK, so the question was, can you write TDD by using random tests? What I think you mean is property-based testing. So yes, you can. I don't have enough experience with property-based testing. I tried it a little bit. It didn't work for some cases. It was really hard to define those properties. It's not the same as random. It's more about like if you can define a property that you are testing. So the answer is yes, but I'm not really sure if it works for all the cases. OK, very good question. How do you refactor a large code base? For example, in this case, we had only one single file, and it was really easy to spot duplications. First of all, if you follow TDD rigorously, you will write everything in the same place and only refactor duplication because it just appears in the same place. You will eventually, you will not have this problem in the beginning. Another problem is that if you have, for example, another code base, then you should probably use some static analysis tools or something. Like, it's really easy to make a mistake and not to see something. For example, I left this I for a really long time, but this was a clear duplication because of the wrong abstraction. So pay attention which abstractions you pick. For example, if you are introducing declarative or you're introducing some library, it may hide some duplication for you. I usually leave those things only when I have clear duplication and I can do it in the refactoring phase. Question is, I skipped some tests and I skipped them because I knew that they are complex. What if I don't do any design and it probably shouldn't work? So I will comment it this way. If you write a test which doesn't work for you and you see that, OK, it takes a lot of effort to implement it, just delete the test or like write a note to yourself and try to find something easier if possible. Because this is how you look at this. And another part of the question is, if I would do analysis of the algorithm, I would probably come with some different implementation. And the point of this talk was that I want to show that sometimes TDD, like sometimes means that most of the times, actually, I apply the same techniques developing web applications. I just like write something, I get a feedback. And this feedback loop just works really nice if you apply correct refactoring phases. Sometimes it doesn't work. It's not 100% bulletproof. But what I wanted to show that first, I attempted to do this algorithm without any tests, and it didn't work for me. Like, I just had ifs inside ifs, whiles, and so on. And it was so hard. And by using TDD, it was very simple. And I think this is really nice. And it works on a lot of algorithms this way. This is not the only algorithm. And not the only simple algorithm. You can apply this on a lot of our algorithms. The question was at which stage I optimize the algorithm. For example, at which stage I deal with performance. So first of all, I have to have passing test stage, which means that my code works. When we speak about non-functional requirements, I usually expect some feature to work. I think this algorithm is like a nice feature altogether, so I would probably wait till the end and maybe even delete all the code because it doesn't perform well, and I will rewrite it. Basically, that's what I did. I just made a recursive implementation by deleting previous code. But I felt very safe because I had all the tests. Okay, so this is a hard problem because it usually involves some end-to-end testing. If you want to properly test this, for example, if you send email and you want to be sure that customer got this email, it involves a lot of the system. And what I would do, if you are thinking about unit testing, I was talking only about unit testing, I would probably use collaboration testing with mocks. And I would be checking if the email sending action was performed. That's what I can check in unit test by using isolation. And if I want to make sure that everything works as a whole system, I need to have fully running system and test it as a black box. So thank you.